हेलो गाइस, वेलकम टू इजी इलेक्ट्रिकल। सो हमने प्रीवियस लेक्चर में देखा था ऑब्जेक्टिव और सम न्यूमेरिकल टाइप क्वेश्चन फॉर ऑटो ट्रांसफार्मर। ओके, तो जिसमें हमने क्वेश्चन नंबर 1 और क्वेश्चन नंबर 2 को कवर किया था। सो इस वीडियो के अंदर हम अपन कवर करने वाले हैं क्वेश्चन नंबर 3, 4 एंड 5 को। ओके, सो दीज आर द क्वेश्चंस व्हिच आस्क्ड इन गेट प्रीवियस ईयर क्वेश्चंस, गेट 2009 IIT Roorkee. Question number 3 and 4, that is a combined question for the combined one statement. Okay, so let's start with this question. So what our question is saying, the statement is the figure above coil 1 and 2, this is coil 1 and this is coil 2 with dot markings. Okay, we have dot marking given here as shown, having 4000 and 6000 turns respectively. This winding have 4000 turns and this winding have 6000 turns respectively. Okay, both the coil have a rated current of 25 ampere. This is also 25 ampere and this is also 25 ampere, right? Coil 1 is excited with single phase 400 volt. This voltage is 400 volt, 50 hertz, right? Now the question starts with, the coil are to be connected to obtain a single phase 400 by 1000 volt auto transformer to drive a load of 10 kV, right? Okay, so now we have a two winding transformer and we have to reconnect that transformer in the ratio that voltage will appear on the secondary side will be 1000, and at the secondary side we have to connect a load of 10 kV. Okay, next is the which of the option given should be exercised to realize the required auto transformer. Okay, so what kind of connection we have to do for getting this auto transformer? Okay, the next question is that in the auto transformer obtained, whatever we connection we are getting, the current in each coil. Okay, let's find out. So first, that is question 3 and question 4 combined, right? We have two winding auto transformer that let's suppose first of all two winding transformer. This is here applied voltage is 400 volt. This is our V2. Here the 25 ampere of current. Here is also 25 of ampere current. Dot projection, dot projection. So what will be the value of V2 is equals to N2 upon N1 multiply with V1. N2 is 6000 upon 4000 multiply with V1, that is 400. That voltage will be 600 volt, right? Say here the voltage is 600 volt. Now we have to reconnect this transformer in a way that we will give 1000 volt in the secondary voltage, right? So let me connect as an auto transformer like this. So let's suppose we have point, I am assuming, okay, he's already given point is that A, B, C, D. Okay, this point is A, B, C and D, right? Now we know this dot polarity, this is positive, negative, positive and negative. We have 600 volt in secondary and 400 volt in the primary, so we have to join these coils in an additive polarity to get 1000 volt in the secondary. Okay, so the auto transformer look like this. Like this. Okay, so in the primary we have to give 400 volt. So 400 volt is that coil number 1 and this is coil 2, this is coil 1, this is coil 2, right? And this is our point A, B, okay, and this is C, D. Okay, now A, D is connected. This is dot polarity here and this is will be dot polarity here because minus plus minus plus, this will give you additive polarity, because this is 400 volt and this is your 600 volt. Okay, due to additive polarity total voltage is 1000 volt, right? That is correct. And we have given that this current is 25 ampere. Okay, and here a load of 10 kilowatt is connected. This is our load value of 10 kilowatt, right? 10 kVA, sorry, 10 kVA. Now the question 3 is which uh, points should we connect? Okay, so in this diagram we can see point A and D is connected and point B is your common point, right? So connect point A and D and common is B. This is the correct answer. And now for the fourth answer, find the coil in each find the current in each coil, right? So for that we will use our connected load 10 kVA. So in the secondary we know the voltage is 1000 volt. So the current is, let me assume this is IL, that is IL is equals to 10 kVA upon the voltage, applied voltage is this, IL value is 10 ampere, as in this finding current is 10 ampere and this is coming like this. Okay, so here the current is 25 minus 10 is 15 ampere, right? Okay, so coil 1 have current is 15 ampere, coil 1 have 15 ampere and coil 2 is 10 ampere, right? So this is our answer for question 4. D answer will be the right answer for this question. Okay, so we completed question number 3 and 4 here. Let's move with another question, question number 5. Okay, we will solve parallelly here. Let me just put the given data. Always write given data. Okay, always. It will help you to figure out what you have to find and what you have to neglect, because not all the things are necessary to find in this question. Okay, given data, because in some question we have some given data to puzzle kind of things. Okay, that is not a necessary data. So avoid this data, just write it down the given data and then think about it, what we have given and what we have to find. Now the question number 5 says a single phase 50 kV. Okay, the rated load or rated volt rated power S rated is 50 kV, right? And that is a two winding transformer, that is 250 volt and 500 volt. Two winding transformer given has an efficiency of 95% at full load. Okay, neta percentage neta at full load, that is 95%, or I can say 0.95 if I will go through a binary system. If it is reconfigured as 500 volt by 750 volt auto transformer, then the efficiency of auto transformer at unity power factor, that cos phi value is unity 1. Okay, let's find it out. So we have given ratio auto transformer turn ratio, that is 500 by 750. So the A auto is 750 by 500, that is equals to 1.5. Okay, and as A auto we can find, that is A auto upon A auto minus 1 multiply with S rated 1.5 upon 1.5 minus 1 into 50, that will give you 150 kV, right? Okay, so we have A auto, S auto. Now we have to find the efficiency. For auto transformer, efficiency is simply output power upon output power plus losses. Okay, so here we can find it out, like S rated into cos phi upon S rated into cos phi plus constant loss, copper loss. Okay, iron loss and copper losses, right? Okay, N auto, we have find it out at a cos 1 phi, at unity power factor, and S rated is 150. 150 upon 150 plus Pi plus PCU. Okay, iron loss and copper loss. Now we have to find the value of Pi and PCU, so we can put it that value in this formula and we can get the N auto, right? So for that we know that for two winding transformer we have a rated losses. Okay, so for full winding transformer, that neta is equals to, that will be your S rated upon S rated plus Pi plus PCU, right? So if we saturate this formula, then Pi plus P copper iron loss plus copper losses will be S rated 1 upon neta minus 1, and S rated is for two winding transformer is we already given 50 into 1 upon 0.95 minus 1. This will give you the answer of 2.6315. Okay, so we have value of P iron loss and P copper loss. So replace this value in this formula. Question number, let's suppose question number 1. So after replacing that value of P iron loss and copper losses in question number 1, then we will get the formula like this: auto is equals to 150 upon 150 plus 2.6315. This will give you the answer of 98.276 percentage. Okay, this will not give you in percentage. If we have to find in percentage form, multiply with 100 also, this will give you percentage. Okay, write this. This is the one method. Okay, the next one, we have one more method, is like method 2, easy one. That method is like just to remember the percentage neta. Okay, the neta, the one formula is the 1 minus copper losses, not copper losses, per unit losses. I'm sorry, per unit losses. 1 minus per unit losses into 100. Right? For two winding transformer, per unit losses, that if two winding transformer giving you 95% efficiency, it means losses are 5%. The per unit losses are 0.05. Simply. Okay. So per unit losses of auto transformer upon per unit losses of two winding transformer, per unit losses of auto upon per unit losses of two winding, that will be equal to S two winding upon S auto, 50 upon 150. Okay, and we have this one also value. This will comes here 0.05, and this will give you the value of 0.0167, right? This is your per unit losses for A auto. If we have per unit losses of A auto, then we can find the value of efficiency of transformer, that is simply neta is equals to 1 minus 0.0167. That will give you the value of approximate values, that is 98.33%, not exact value, approximate value. Okay, so that can be a one formula also. It's a simple one, because we know that every machine has a efficiency of 100%, total 100%. Okay, if we minus the losses, then we will get the actual efficiency of that machine or a transformer, whatever we can say. So we can directly, if we are directly minus that efficiency from 100%, then we will get the percentage losses only. Okay, so that percentage losses, if we minus from the actual 100%, if we are in the 100%, we are minusing that loss percent part, then we will get the efficiency, actual efficiency. Okay, so here uh, answer C, that is your correct answer, right? So we finished question number 3, 4 and 5. Okay guys, let's meet in next video for question number 6, 7 and 8. Okay, thank you so much.